Today in the bench, something new to play with. There we go. Hickok model 517. As you can see, this one is fairly clean. Ugh. Probably not used in a long time. Today I'm just really going to try to see if I can get it going and calibrate it a little bit. Not mine. I'm doing it for a friend in the radio club who needed an oscilloscope to play with. So we'll look at it and see what I can fix up, if there is anything to fix. Before I get started on working the scope, I thought I'd give a little background information on it. I don't have an exact date when it was introduced to the market, so my guess is about 1977 or 78. Seems this was the golden age of cathode ray oscilloscopes. In a 1981 magazine, I found a review of currently available scopes. It was a listing of about 9 pages long, with over 100 scopes, and perhaps 15 to 20 different manufacturers. You could get everything from a dubious home kit for $39.95, all the way up to a top-of-the-line Hewlett-Packard for about $8,500. The list price for the 517 was $995, which would have been a good value for money, given its 15 MHz bandwidth, 2 channels, and some triggering features. Like most scopes I found in that list, it was marketed towards repair and service shots. The scope was mostly clean, though it looks like it's been in storage for a while, and there is one knob on the front that will need a little fixing. And as you can see, it's quite a hefty beast, obviously designed so that it could be lugged about if required. Oh, by the way, Hickok still exists, and it's even at the same address where this scope was made. Though today it looks like they largely manufacture automotive diagnostic tools. Alright, I've done a couple initial checks. The line cord was fine, it's not broken, and the fuse is intact. I've got it plugged into the dim bulb just in case something is shorted on it. And I've got it on medium power. I believe the on switch is right here. Something comes up, hopefully. That's on. Now these old ones, the horizontal position, let's see, channel A has to go on. Let's see if we get a trace here. Nope, no auto finder on this one. Position. Nope. Can't seem to get anything on that. No straight line. Well, let's run a signal through it and see what we get.
5 minutes later.
So I got it hooked up to a signal generator with a 1 kilohertz power. And let's see, that's 10x. That's not going to work. Ah, there we go. Ah. Aha. We get a nice square wave. A little jiggly, but we're getting a square wave. Huh. That's a nice sharp square wave. Yeah. Invert ground. Huh. Alright, well, channel A is working. Let's try channel B. Yep. Ooh. That don't look very good. It's chopped in half. So I think channel B is buggered. Yeah, doesn't look good. Yeah, channel B looks buggered. Yeah, we'll have to check that. Anyway, channel A looks nice. Alright, well, let's do a quick calibration a la manual and see what's going on here.
Warning, 40,000 volts now in circuit.
To properly do the calibration, you have to open up the box. Now, even before I open the box, I'm going to give you a few places to be wary of. The operating voltage of the CRT is negative 1900 and positive 1900. So that makes a potential of 3800 volts. Touching one of these high voltage rails will really spoil your day. First we have the power supply, which is contained in this box with a big sign that says caution, high voltage. Anything in here is dangerous. Next are these potentiometers up here that control the astigmatism and focus. Both of these have a potential of over 1900 volts. Next we have this board here, which has a potential on it of 250 volts. Finally there is the CRT itself. Even though it's well shielded, you should always avoid touching it. On the back side, there's really just one spot to look out for. It is this terminal strip here, which has up to 260 volts on it. Now, with all that being said, let's take this guy apart. So, reviewing the manual, I think what we should do first is a calc, as it says that the traces could be off if the calc isn't correct, and I think this is the right way to get this off. I think what happens is these come off here. Yeah, there's the holding it all together. Oh yeah, that just comes off like that. Really easy to take apart. There we go. Ooh, look at the size of that CRT. Yeah, you gotta be very careful. That's all super high voltage over here. There's the cap. Is it ever nice and clean inside? Ugh, beauty. Not much to it. Not much to it at all. And that's the high voltage stuck in there, so we'll leave that alone for now. There's nothing I can do in there. Not hot. But it is very clean inside. Let's take a closer look. Look at that. Oh, a goody analog goodness. This one that's bent over there. There's the pots. Reefa cap. That's a good cap there. Not going to touch that one. Power supply should be okay. The other board's on the other side. Lovely. I like the way this thing stands up. Oh yeah, that's nice and clean. Caution, high voltage, do not touch. That's the high voltage over here. Sweet. Sweet, sweet, sweet. Oh, and it's got a grounder up there, so it should ground the CRT nicely. Anyway, I've got one. Don't want to stick my finger in there. Pokey stick.
A little later.
You can see this one here is a little damaged. I doubt that has anything to do with that. Traces look a little bubbly. So it's been in a shop. Everything else looks okay. Attenuator. That's the high voltage up there. I'll make sure I'll drain those cats. But it does have a electrostatic drain here. Oop, can't see that. Up here, there's an electrostatic drain onto the chassis, so it drains off the CRT when it's turned off, which is nice. I can't see much wrong with it. Off the top of my head. Might just need a little cleaning. I'll go find all the calibration points and then see what we got.
A few moments later.
My first thing to test is the voltages, and there are 1, 2, 3, 4, 5 across this terminal strip up here. And of course, I wrote them all down in my notes, and I'll keep them. The real funny thing is that the voltage ranges are really off. I mean, they're not particularly accurate. 240 to 260, that's 5%. 120 to 128, 4.5 to 5. Yeah, so they're not particularly, it's not definitely not a Hewlett-Packard instrument where you get like 0.1 of a volt. So let's power this up. Let's see, I think it also says to let it sit for 10 minutes.
A few minutes later.
Okay, we'll let that sit enough now, and we'll test the voltages. So the first one is red and white. That should be 240 to 260. What are we reading? 248.2. Orange and white should be 120 to 128. $128.2. Little high, but not much. 128. Red should be 4 to 5.5 or something like that. 5.0. Okay, that's nice 5 voltage there. Orange should be 14 to 15. 14.8. Good. 8. And blue should be negative 14 something. Negative 14.8. So those two are the same. That's good.
You did was say,
No, don't say that.
peanut
No.
butter sandwiches.
Well, didn't catch it on camera, but released the magic smoke in there. You can see it coming out. I just turned it on. Oops, still on. No, it's off. So blew a cap in there somewhere. So I'm going to let it cool down. I'll go in there and see which cap blew. It's on the power supply. Didn't seem to do any damage, but we'll have to have a look inside. Oh well. Them's the breaks with these old... Drain this here. Get the box out of here. Maybe a little room to work on. Unfortunately, too many wires to disassemble. Ugh, messy stuff.
12 seconds later.
I had to rearrange the camera to get it in view, but anyway, the high voltage box is covered with that thermal paste. You have to be very careful with gooey stuff. Anyway, let me see here. Put this over here. So what's in here? So under here are the power transistors. That's on the pack. That goes there. It goes into the heat sink of the whole thing. Let me zoom in here. This one here, this is the cap that blew. It's bulged out on the side, as you can see. So what I think I'm going to do is replace all the caps in here. I think there's 1, 2, 3, 4, 5, 6, 7, 8 in total. The only problem is this is a really oddball 2.2 at 350, and that's an oddball 68 at something. Don't have any of those. I have to order some up. So it looks like we'll be delayed until I get the order in. Anyway, you can see the flyback transformer there, putting up the 1500 volts. Or 1900 volts. This is a... let's see. Zoom out a little here. Oops. Over here we got most of the logic circuit. That's a triple nickel. It's all nicely socketed, which is good. So it should be easy to replace if any of these things are bad. These are all just standard TTC logic. Not much else in here to have a look at. I think that's the 5-volt regulator over here. That's the diodes going out to the big cap outside. And that's about it, really. So I'll get that done, and when they come in, we'll see what happens next. I guess that's it for today. Riley, if a box comes in, are you going to help me open it? I guess you're just too old now. Talk to you later, Riley.